Hello and welcome. Assalamu alaikum. This is Usman Mahmood. Welcome to Analysis 360 YouTube channel. Dear students, today I am going to discuss about dimension in physics. So we know there are two types of quantity in physics: fundamental quantities and compound quantities. So there are we also know there are 7 fundamental quantities. So let's have a look in the board. There are 7 quantities and their unit and dimensions. So we know the first quantity of fundamental quantities, length, so unit meter and dimension L. Mass, unit kg, dimension capital M. Time, the unit of time second and the dimension is T. Electric current, the unit A, dimension I. Temperature, unit Kelvin and dimension theta. Luminous intensity, unit CD. CD comes from candela and dimension J. And last quantity, amount of substance, which unit is mole and dimension is N. So these are 7 quantities, their units and dimensions. So actually dimension is the power of fundamental quantities. Actually dimension is the power of fundamental quantities, and we know in a compound quantity depends on 2 or more than 2 fundamental quantities. So let's have a look. Now we are going to find the dimension of different compound quantities. So number 1 is velocity. We know velocity means distance by time. So here we know the dimension of distance is L and the dimension of time is T. So this is LT inverse 1. So LT inverse 1 is the dimension of velocity. So let's take another example. So this is work. We know work is the multiplication of force and displacement. We know work is the multiplication of force and displacement, and we also know force equals to mass multiplication of mass and acceleration. And displacement. So mass is a fundamental quantity, and as we know acceleration equals displacement by time square into displacement. So finally it can be written that mass and displacement into displacement equals to displacement squares. Displacement square by time square. So So these all are fundamental quantity. So we can say that work depends on three types of fundamental quantity. These are mass, displacement and time. So the dimension of mass we know m, the dimension of displacement L, so the power of displacement square by time, dimension of time equals to capital T. So and we find m L square T inverse 2. So m L square T inverse 2 is the dimension of work. So dear students, you can determine the dimension of different types of compound quantities by determining the fundamental quantities in the compound quantities. So you can pause the video and write down the answer. So now there are many uses of dimension in physics. Now I am going to discuss about very common use of dimension. This is the authentication of accuracy of an equation. So let's start. We know there are four equations of motion, and we can easily authenticate the accuracy of the equations of motions. So let's start. So number one equations of motion is v equals to u plus at. If we find the dimension of three parts of the equation remain same, we can say that the equation is authenticated and it is verified equation in physics. So there are three parts of the equations. So first part equals b. So b means velocity. So velocity means distance by time. So dimension of distance L, the dimension of time T. So this is LT inverse 1. So actually dimension is expressed with third bracket. So we can put a third bracket in LT inverse 1. Okay. So second part of the equation, u. So we know u is also velocity. So velocity. So we know velocity equals to distance by time. So dimension of distance L and the dimension of time is T. So this is LT inverse 1. So LT inverse 1 is the dimension of velocity. And final part of the equation is AT. So final part, third part or final part. So third part AT. So AT means A means acceleration, and T means time. And acceleration equals to displacement by time square and time into time. So if we divided time square by time, so we will find displacement by time. So dimension of displacement is L and dimension of time is T. So this is LT inverse 1. So dear students, we have found the dimension of three parts of the equation are remain same. So we can say that the equation is absolutely verified and authenticated equation in physics. So you can pause the video and write down the answer. So let's take another equation of motion. So let's take another equation. So another equation is S equal to U2 ut plus half of at square. So first part of the equation, first part S. So S means length. So the dimension of length equal L. So second part of the equation, second part equals ut. We know u means velocity and t means time. So velocity equals to distance by time into time. So time cancel out. So finally we get distance. So velocity of distance L. And finally the third part of the equation, third part is at square. So here is half at square. We know half is a number and it has no dimension. So we can write at square as the third part of the equation. So we know A is acceleration, and T means time and it is square. So acceleration means displacement by time into time square. So if we divide time square by time, we will find finally displacement into time. Acceleration actually equals to displacement by time square. So if we divide time square by time square, so time square is cancel out. So finally we get displacement. So displacement, the dimension of the displacement L. So dear students, finally we can see that every parts of the equation and the dimension of every parts of the equation are same, absolutely same. So dimension of first part L, dimension of second part L, and dimension of third part is L. So we can say that the equation of motion is absolutely verified equation and it is a authenticated equation. So dear students, no more today. We will see in the next video. So thank you for watching my videos. If you like the videos, please subscribe my channel. Thank you.